to make sure that I'm in front here all the times. So today we're talking about something called logarithmic differentiation, and this is kind of just a sort of an odd situation, but it can be kind of helpful. There are some times when we are taking logarithm, or when we're taking the derivative, that it is actually advantageous for us to do it in a slightly different way, okay? And that slightly different way is called logarithmic differentiation. I'll kind of show you about that process here in a second. The thing to remember, and the reason why this phenomenon is used, is because of the properties of logarithms, okay? So you probably have them on your paper there. We discussed them in pre-cal. I just kind of said them very quickly. But just to recall them, that is the log of a product is equal to the sum of the logs, yes. So log of A times B is equal to log of A plus log of B. And you remember that you have to have the same base on each one of those, but that's not a big deal. The log of a quotient is equal to, yep, you guessed it, the difference of the logs. And then the log of A to the C is equal to C times log A. Kind of reminds us of a power rule, right? Just at least the moving the exponent to a coefficient kind of thing. All right? So what these do, if you can kind of think about it, is it turns something which can be complicated, like a multiply or a divide or an exponent, and it turns that multiplication into an addition, which is always good. It turns this division into a subtraction. I mean, I'm not really a big fan of subtraction, but I'd rather be doing a subtraction than a division, wouldn't you? Yeah. And the same thing here. If I had the choice of taking something to a power versus doing some multiplication, would you rather do the multiplication? Yeah, okay. Here in a second, everything that we're working on today hinges on that part where we're going to be taking the derivative. And so my question is, would you rather take the derivative of something that looked like this or of something that looked like this? If you have the derivative of something that looks like this, what sort of rule are you going to probably have to use? Product rule. First times derivative of the second plus second times derivative of the first, right? But if you do the derivative of this, you can just do derivative of this one plus derivative of this one. Same thing here. Oh my gosh. Everyone's most annoying derivative rule ever. You'd have to, if you're taking the derivative of something inside there, it'd be like quotient rule, right? Here, just the derivative of this part minus the derivative of that part. And the same thing over here. So that's kind of what we're going to do. And we might start off with like a ridiculously hard one just so you kind of see what's going on with all this. Because if you can handle the really hard one, then you can handle all these other easy ones. So there's really no theory other than those properties which you already saw. Let's turn the page. Okay, I should have given you more problems, but that's okay. Let's look at number 7. Yeah. All right. The instructions, which are actually on the front page, says use logarithmic differentiation to differentiate each function with respect to x. Okay. So, oh boy, anybody feel like taking the derivative of this? I'm thinking product rule, right? And the product rule for this term is going to have a chain rule, and the product rule for this one is going to have a chain rule. You see that? Let's go ahead and rewrite this term slightly with this, remove that radical and write it with an exponent here. So we'll just change this very quickly. So 2x to the 5th squared times 2x to the 4th plus 3 to the 1/3 power. Okay? So I'm told to find the derivative. we are not going to find the derivative that long, hard, annoying way of product rule with chain rule 2 times, okay? It's going to get messy. The answer is messy, but it doesn't have to be so annoying for the whole process. So here's the key to logarithmic differentiation. Step 1, take the natural log of both sides. So the natural log of y equals the natural log, and I'm just going to have to put like 3 parentheses. 2x plus 5 squared and 2x to the 4th plus 3 to the 1/3. Like I said, we'll do a hard one here initially, and then the other ones through it. Step 2. Now take the derivative of both sides. That means take the derivative. Actually, scratch that. That's not what we're going to do first. Step 2. Apply properties of logarithms. Notice that I have the natural log of A times B. Would you agree with that, Rigel? Yeah. Okay. So let's apply the product rule here, okay? The product rule for logarithms. And rewrite this as the natural log of 2x plus 5 squared plus the natural log of 2x to the 4th plus 3 to the 1/3. That's just natural log of A plus natural log of B. Over here I wrote log log, and over here I'm doing that with natural log, but remember natural log is log with base E. And that's maybe like Harley, does that make sense? Mm-hmm. We're going to split it up. I actually can take this one step further using the properties of logs. You see what else I could do, James?
Put the exponent in front of the...
I could. So I'm going to say natural log of y equals, bring that 2 out here, 2 times the natural log of 2x plus 5 plus 1/3 times the natural log 2x to the 4th plus 3. And I'm probably going to carry this over here. I'm just going to rewrite that up here. Natural log of y, 2 natural log 2x plus 5 plus 1/3 natural log 2x to the 4th plus 3. So I'm just rewriting that down here. Okay, now I've done everything I possibly can. Now you might say, can you take that 4 and bring it out here? No, because that 4 is inside this sum. All right, James, make sure I'm in the frame here. You might say, oh, can we split this up, this 2x plus 5, and split that up? No, why not? It's inside, and it's a plus. And this over here says it's the log of A times B. So this is as simple as it gets. So now we'll apply step 3, which was take the derivative with respect to x of both sides. So the derivative natural log of y is 1 over y times the derivative of the inside. So dy over dx. Alright, over here, right hand side, the derivative of 2 ln 2x plus 5 is going to be 2. That's that constant multiplier. What's the derivative of the natural log of anything? One over what?
Anything.
1 over anything, so 1 over 2x plus 5 times the derivative of the anything. So derivative of 2x plus 5, 2.
Wait, so we have the 2 on top because we pulled out the outside, right? And
Yep.
it's 1 times that, right?
Right.
Okay.
Yeah, it's 2 times, if you want to be real technical about it, it's 2 times 1 over 2x plus 5 times 2.
Okay, that's what I thought.
Plus, for consistency's sake, I'll say 1/3 times 1 over 2x to the 4th plus 3 times 8x. Still good? Kind of want to clean this up a little bit here. So I've got 1 over y dy over dx on the left hand side equals, this is 4 over 2x plus 5 plus 8x over 3 times 2x to the 4th plus 3. What am I looking for here? What the instructions want us to do? Find the derivative. So find dy over dx. So in order to get that, I'm going to multiply this side by y, and I'll multiply this side by y. So dy over dx equals 4 over 2x plus 5 plus 8x over 3 times 2x to the 4th plus 3 times, now what is y? That, right? Y equals all this, so parentheses 2x plus 5 squared and 2x to the 4th plus 3 to the 1/3. Okay, looking better. This is an answer. It's not a fully simplified answer, but I didn't give you too much homework, so we're gonna push this sucker to completion here. Okay? So a fully simplified answer is going to involve combining these terms, okay, and then multiplying it over here and see what we get. Right? Now, if I'm going to combine these terms, I would need to find a common denominator, right? The common denominator between 2x plus 5 and 3 times 2x to the 4th plus 3 would simply be all of those guys multiplied together, right? So we're going to have 4 over 2x plus 5 times 3 over 2x to the 4th plus 3 times 3 2x to the 4th plus 3 plus 8x over 3 times 2x to the 4th plus 3 times 2x plus 5 over 2x plus 5 times all of this stuff. 2x plus 5 squared times 2x to the 4th plus 3 to the 1/3. So let's see, 4 times 3 is 12, so I've got a 12 and I'm going to distribute it. So 4 times 3 is 12. 12 times 2x to the 4th, so that's going to be 24x to the 4th. Y'all, are y'all with me? Can you see that, Rigel? I don't feel like you're not able to see this.
Yeah, I can.
Okay. Are you, so the question is, how good are you on your Algebra 2 brush up? Can you handle this thing plus this thing? The way you get a common denominator is you take this denominator times this denominator over itself. And then you take this whole term and multiply it by this denominator over itself. But we did that enough times in Algebra 2 that you remember how to do that. So that's why I multiplied by this term over here by 2x plus 5 over 2x plus 5, and I multiplied this term over here by 3 2x to the 4th plus 3 over 3 2x to the 4th plus 3. Now when I do that, the 4 times 3 is 12, and then I distribute that 12 inside the parentheses. So I have 24x to the 4th plus, what's 12 times 3? 36. And then plus, and that's nice that it's plus, but not minus. So 8x times 2x and 8x times 5. So 8x times 2x is 16x squared plus 8x times 5. So that's 40x all over 2x plus 5 times 3. Yes.
Sorry, man.
Sure, what's up?
EOC and a plan for Algebra 1, is that already something we reuse year to year to year? Like, is it already in existence? Do you know what I'm talking about?
I don't know. Hold on a second.
Okay.
Y'all keep working. We're just simplifying that denominator there. No.
Yeah, I was gonna say this is more complicated than just change. Especially since you have to multiply by 1 over y. You're doing general instead. I don't know. The other one, like, this would have the answers. You have to simplify, multiply by this. Not you. Anyway. Yeah. I did not even. This was a bit of my Friday. Like a trigonometry test this Thursday. Rick one. Or actually I can't remember if he postponed it since like after classes
Yeah.
go on Tuesday, Thursday for like trigonometry. Oh, that's right. That's right. My sister's gonna have a game today. But it's have you watched Captain
Hey, we have to get
Marvel?
y to the.
Yes.
What do we have to do with y? How do we multiply by y?
Just multiplication.
Yeah.
I mean,
Why didn't I think about that?
yeah.
Okay, but like what's? Do I have to get get a common denominator?
No, it's
It's just-
multiplication.
so
You'll
it's
have to like I think it's like not factoring, but
Distribute.
yeah.
Alright. We got times the 3, and then we've
Give me
got,
a second.
is it
This guy's
2x
finishing Sunday.
to the 4th? Okay, so that's all that nonsense. Times 2x to the 5th squared times 2x to the 4th plus 3 to 1/3. Oh my gosh. Are we good? Are we looking solid? Okay. What can we do now? I'm certainly not going to FOIL this out. I certainly can't even anyway because those are powers. But the good thing I left, and I'm not going to FOIL this out because notice I have 2x to the 5th and 2x plus 5, 2x plus 5. So that will cancel out one of those. And this is the equivalent of a 1. Right? So I have 2x to the 4th plus 3 to the 1/3, and I have 2x to the 4th plus 3 to the 1st. So anytime you have blah to the 1/3 over blah to the 1, you can think of that as blah to the 1/3 minus 1. Because if you bring this one up, then it was yeah, times blah to the minus 1. It's blah times blah, which is the same base, and so your property of exponents is going to be 1/3 minus 1. So 1/3 minus 1 is equal to -2/3. Okay? So -2/3 in the numerator or a +2/3 in the denominator. So our final answer should be, in order of decreasing exponent, 24x to the 4th plus 16x squared plus 40x plus 36 times 2x plus 5 divided by 3 times 2x to the 4th plus 3 to the 2/3 power. Are we liking that? I'm liking that, but that's a whole bunch of algebra stuff. Can we do anything more? Well, if we wanted to, we could distribute that 2x plus 5, or we could maybe factor out a 2. But at this point, I'm like, okay, we're done. It just depends on what sort of answer that they're interested in here. Let's see what sort of answer they're interested in here.
Oh, they changed the words.
We've got yeah, they changed that 2/3 back into the square and the cube root. There's the 3. What do we have here? We've got the 2x plus 5.
Well, they pulled out a 4 from all of them.
Pull out a 4, yeah. But that's strange. They had a term that we don't have a term. They've got 3 and we've got 4, right?
Yeah.
Did we do something incorrect? That was the 4th? Am I right here? Was that 2x to the 4th? And then 8 squared. Think you can pull out another 2x plus 5. Hold on. 4 times 10 is 40. X. But they've got x to the 4th. Okay. I am not sure exactly what's going on with that final simplification answer. So we're just going to kind of...
We did this and we just messed up.
Yeah. So let's just, well, it is possible that we made a mistake somewhere in there on the algebra. That is possible. Let's look at the
Oh,
unsimplified.
it said 8x to the 3rd, isn't that?
It's 8x.
To the third, not 8x.
Okay. 8x to the third,
Mm-hmm.
which would be an x to the third, which would mean 8x to the third. So this would mean 8x to the third. So when I multiply that times 2x, I get,
Wait, why is
16x.
it to the third?
because this right here, so we have 1/3 times 1 over the anything times the derivative of the anything. It's the derivative of 2x to the fourth is 8x to the third.
Dang, we messed up from the beginning.
Yeah. Now, here's what I would like for us to do
Oh
on these problems. Right. I want you to kind of I want to show you this because then I'm at this point I'm not interested in chasing this whole thing down. Notice the unsimplified answer. dy over dx is equal to y times that derivative there, which we had at this point right here. We had dy over dx equal to this whole expression times y. I'm okay with you stopping at that point. Okay, but it is possible for you to get carried through all this stuff, but at that point it's twice as much work of algebra than it is calculus, and you already did Calc 1, so I'm interested in moving on to more calculus type things. Let's pick another problem. Not sure. Oh, I already did. Let's go number 1, since that's kind of that easy sort of stuff. And so show how we might apply the same thing here. So step number 1, take the logarithm of both sides. So ln y equals ln of 5x times x cubed. Let's apply the property of logarithms. So ln y is equal to, property of logarithm says I can take that exponent and turn it into a multiplier, right? So I'm going to take that x cubed and bring it up here. Alright, now let's go ahead and take the derivative of both sides. Derivative of ln y is going to be 1 over y times derivative of the inside, so derivative of y is dy over dx. When you think about taking the derivative of this over here, what comes to your mind, class? X cubed times ln of 5x. Sure.
I thought the exponent had to be outside the parentheses to move over.
Ooh, yeah, it does. I like that. Okay. So you're telling me that, and I think, yeah, I can, yes. So we can fix that real quick. I have ln of 5 times this. So I'm going to split that up into ln 5 plus ln of x to the x cubed power. Which equals, now that ln 5 is fine, but this can go right there. So plus x cubed ln x. Good catch there.
So how come we can split it that way?
Okay, because it follows the pattern A times B.
Oh, okay.
So that's how we split that up. And then this follows the pattern here. What he was saying is that, he said, yeah, you were pulling that x cubed out here in the front, but you can't because that x cubed is only affecting the x. It's not affecting the 5 and the x, which he was correct. Okay, so we're taking the derivative of this. Derivative of the natural log of 5.
1 over 5.
Times
Times 0.
of 0, yeah, it's 0. Natural log of 5 is a number, so it's the derivative of that is 0. Now, let's take the derivative of x cubed times ln x. For the sake of time, I'm going to tell you this is a product rule situation. Okay? So we have the first, which is x cubed, times the derivative of the second. The derivative of ln x is 1 over x, plus the second, so ln x, times the derivative of the first, which is going to be 3x squared. Also, for the sake of time looking here, I have x cubed and then x here, so that's going to cancel, turn into x squared. Multiply both sides by y, so multiply this side by y, multiply this side by y, and we have dy over dx equals y times x squared plus, we normally write the coefficients first here, 3x squared ln x. Looking good? Alright, now let's pick a really hard one. Like number 10. Anybody feel like doing the quotient rule with product rule in the denominator and unit the chain rule times 3? Nope, me neither. Let's do logarithmic differentiation of this one. So let's take the natural log of this side, so ln y equals natural log. Now let's just be smart here. This is a, b, c. Where this is a, this is b, and this is c. Can you, using the property of logarithms here, properties of logarithms, break this down?
Yeah.
Okay. It's going to be natural log of a minus the natural log of b times c. Because the natural log of anything over something else, right? I get in a look of confusion on your mind there.
No, it wasn't, but I got it.
Okay. Alright. Now, let's expand this one more time. So, natural log of y equals natural log of a minus, and I'm going to split this one up. So, natural log of b plus natural log of c. And if I distribute that minus, I have natural log of y equals natural log of a minus natural log of b minus natural log of c. Make sure we're getting the whole thing in the frame here. Any questions we have so far? Okay. Right, because it's minus this term. It's like this. Probably remember your arithmetic here. So minus this. Now if I replace this with this, then that minus is in front of the whole thing. So that's why I've got that minus there. Now I'm going to write natural log of y equals natural log of 5x squared plus 1 cubed minus natural log x cubed plus 2 to the 5th minus natural log x minus 4 to the 4th. Okay. can then apply the power rule. So I'm just gonna do scratch out the 3, put it there. Scratch out the 5, put it there. Scratch out the 4, put it there. We have less than 10 seconds, but we're gonna do this real quick. Take the derivative of both sides. Derivative of ln y is 1 over y times 2 over dx. The derivative of 3 times the ln of anything is 3 times 1 over the anything, 5x squared plus 1, times the derivative of the anything, 10x, minus derivative of this, 5, 1 over the anything, so x equals 2, times derivative of the anything, 3x squared, minus 4, 1 over the anything, x minus 5, times the derivative of the anything, 1. See how we were able to do that? Okay.
And then we times it by y.
Multiply it by y and declare yourself finished. Maybe do a little bit of cleanup with the numerators. 3 times the 10x, make that 30x. Make this 15x squared and make this 4, you know? But yeah, you caught yourself done. The hardest part at this point is just going to be applying those properties of logarithms, okay? Finish up that other one. Work through all these problems. See if you have any questions on that. We walk in tomorrow, and we'll plan on grading all that. All right? That's logarithmic differentiation, folks.
Can we turn